So we're going to start this one class out with a few questions that are taken from your books, which you're welcome to read them, but I've copied them here and they're also on your student note sheet, so you really probably don't have to take a look. But I'd like you to take a few moments to try to answer them on your own before I give you the answers and see what you're thinking. I think some of these you're going to find to be pretty easy at this point. So number 81, free fall is motion in which gravity is the only force. So is a skydiver who has reached terminal speed in free fall. So look at your notes. What does it say about terminal speed and free fall? So are they in free fall? Second question, is a satellite above the atmosphere that circles Earth in free fall? So think about that. Think about the definitions you know. Number 57, 3 parachutists, A, B, and C, each have reached terminal velocity at the same distance above the ground below. A, from fastest to slowest, rank their terminal velocities. So take a look at those 3 pictures that you have at the top. You've got different masses for each of them. And what do you think about their terminal velocities? And then B, from longest to shortest, rank their times to reach the ground. So then let's take a look at some answers. So for 81, no, there is air resistance also acting. So free fall means free of all forces other than that due to gravity. So an object may experience air resistance. A freely falling object experiences only the force due to gravity. And B, yes, although getting no closer to the Earth, the satellite is falling. And we would talk more about this in chapter 10 if we got that far, but that is the case for satellites orbiting Earth. So for 57, when we are ranking them in terms of their terminal velocities, it's going to be C, A, and B, and that's based on their weights. Okay, because their masses are different. So we're going to rank those. And then from longest to shortest, rank their times to reach the ground. This is going to be exactly the opposite of that. So that's going to be B, A, C. So B is going to have less, is going to fall there, going to take the longest time to actually hit the ground. And while C is going to take the shortest amount of time. So another question. Suppose you hold a ping pong ball and a golf ball at arm's length and drop them simultaneously. You see them hit the floor at about the same time. But if you drop them off the top of a high ladder, you'll see that the golf ball hits first. Explain. So why is that? What's different if you just drop them at arm's length onto the floor versus when you climb up on a ladder? So hopefully you recognize that at low speeds, accelerations are nearly the same because there's not a whole lot of air resistance. From a greater height, there is time for that air resistance to build up and more noticeably show what effects it has. So a quick video on a skydiver. So here's the video.
When a skydiver jumps out of a plane at 3,000 meters, her speed goes through some big changes. So what's happening to the forces as you fall through the air? The force of gravity is always trying to pull us towards the Earth. Before the skydiver jumps, the floor of the plane provides a counterforce, which balances the downward force of gravity, right up until the moment she steps out. Gravity immediately pulls her towards the ground, and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity. When forces are balanced, the speed remains constant. That doesn't mean she stopped falling. It means she stopped accelerating. She's still doing a steady 55 meters per second, and hitting the ground at this speed isn't a good idea. To slow down, the upward force needs to be greater than the downward force. When the parachutes open, air resistance suddenly becomes much greater than gravity. The forces are no longer balanced, and this changes her speed. She slows down. Because she's slowing down, air resistance decreases until it balances gravity again, and she reaches a much slower constant speed. Approaching the ground at 5 meters per second is a much better idea. As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her very quickly.
All right, so
for skydivers to land safely, they need to understand forces and use air resistance to slow themselves down.
So there's some really good information in that video, and I like showing it because I think they do a good job with the graphics showing you about the forces and what's happening as the skydiver goes down. So I want to kind of look at the same information that they just went over, but only on this worksheet where we have this jumper coming out of a plane, and we're going to go through the forces and look at what's happening. Okay, so again, you are on page 41 in your blue packet, and we're going to work through this falling and air resistance page. So Bronco skydives and parachutes from a stationary helicopter. Various stages of fall are shown in positions A through F, letting downward be positive in direction, and using Newton's second law, we can say that the weight minus the air resistance is the net force, and that divided by the mass will give us the acceleration. So while they are using W minus R, we normally use F gravity minus F air divided by mass. Okay, so what we have here is that it says find Bronco's acceleration at each position. Writing the answer in the blanks to the right, you need to know that Bronco's mass is 100 kilograms, so his weight is constant at 1,000 newtons. Air resistance varies with speed and cross-sectional area as shown. So let's go down through this. So at this point in time, his net force is down. So his net force is only going to be 1,000 newtons down. So A equals F net over M, and his mass is 100 kilograms. So we've got this is 1,000 divided by 100. So we've got 10 meters per second squared down. So for B, we end up with his net. Looking at his net here, we get 600 newtons down. So now we're going to take 600 divided by 100, and we get 6 meters per second squared down. This one, they're equal, so F net equals 0, so the acceleration equals 0. This one, the net is 200 newtons up, so his acceleration is 200 divided by 100, which is 2. So his acceleration is up, but remember, he's still moving downwards. This just now means that he's starting to slow down. So now his air resistance is 2,000. His weight is still 1,000, so his net force is 1,000 newtons, and that is up. So his acceleration is 1,000 divided by 100, which is 10 meters per second squared up. And now they're balanced, so F net equals 0, and his acceleration is equal to 0. So let's look at a couple of these and see what else do we already know. So free fall, when he only has the force of gravity acting upon him, that would be in A. This is free fall. He only has the force of gravity at that point in time. When he has these balanced forces, he has reached a terminal velocity. His acceleration was 0. And then he reaches a different terminal velocity, which, like they showed in the video, it's much slower down here when his parachute is open, and this way he doesn't actually hit the ground at a really high speed and hurt himself significantly. So when his speed is the lowest, his acceleration is the most. In which position does Bronco experience a downward acceleration? So we can look at all of those. That would be A and B. And then after that, it goes through 0, and then it's upwards, and then it's 0 again. Number 3, in which position does Bronco experience an upward acceleration? That would be D and E. 5, which is, does he have constant velocity? That would be C and F. I skipped one. Number 4, when Bronco experiences an upward acceleration, his velocity is still downwards. Number 6, in which positions does Bronco experience terminal velocity? That's still C and F. In which position is his terminal velocity the greatest? That's before his chute opens, which is up there at C. And if Bronco were heavier, his terminal velocity would be greater. Right. So now that you've worked through this sheet, I'm going to have you work through a couple more things on your own, and then we'll go over the answers in the next video. So go through page 42 and 43. It's the same process, the same type of information. You're looking at this exact same thing. You're just looking at it from a slightly on a different worksheet.